Welcome back, everyone,
for today's video.
Hey, it's Ajay. If you don't follow chess, you're seriously missing out, because this seemingly innocent board game where two players just stare at a board in silence has been rocked by more controversy than your favorite reality TV show. From Magnus Carlsen deciding to quit the World Rapid Championship because he was asked to change out of his genes, to more disturbing ones like Russian player Amina Abakarova allegedly caught on camera smearing mercury on her opponent's pieces.
What the shit?
But all these stories pale in comparison to the biggest crisis facing chess today, which is cheating. In recent years, as chess has exploded in popularity and engines, computer programs that play chess, have gotten stronger than ever, cheating has become a major source of controversy and drama. And it's not just some fringe problem. You've probably heard of the Magnus Carlsen and Hans Niemann saga that resulted in a $100 million lawsuit. And even top players like former world champion Vladimir Kramnik have lost trust in platforms like chess.com and Lichess, and are openly questioning whether these platforms can detect the more sophisticated kinds of cheating, and have been openly accusing players of suspicious or interesting play.
Yeah, something tells me he was a little too strong. He was a little too strong for his level, but okay. If you are not too naive, you understand the scale of a problem. Now, who is this genius? But no doubt the major part of the game was played beyond the level of, okay, of course, report immediately. I mean, no doubt about this player. Absolutely no doubt. So, reporting.
So while all this drama has brought a lot of attention and awareness to the problem of cheating and to the game in general, it has also brought in a ton of controversy and speculation and paranoia. And that's what we're going to address today and balance that out with some more awareness. And we're going to do that by exploring three topics. First, we're going to have a look at chess engines, how traditional and AI-based chess engines work and how they revolutionize the game of chess. And next, we'll have a look at cheating and cheat detection, how the rise of these engines has brought along unprecedented levels of cheating in chess, and how platforms like chess.com and Lichess have been evolving their systems to both detect and prevent cheating from happening on their platforms. And finally, we'll examine the impact of all of this on the chess world. We'll have a look at some major controversies like the Hans Niemann saga, did Hans actually cheat? And discuss how we can all grow this community and engage in chess in a way that's healthier, more well-informed, and just rooted in trust.
We will have a nice video probably he will make on YouTube.
We're going to start with what exactly is a chess engine. A chess engine is just a computer program that's been designed to analyze chess positions and suggest the best possible moves in a matter of seconds, often playing better than any human alive. For some perspective, Magnus Carlsen, arguably the greatest player of all time, has an ELO rating of about 2850. But the best chess engines have ELO ratings of over 3,500. So the greatest human to have ever played the game wouldn't win a single game against a chess engine. Okay, so how do these engines do it? At its core, an engine does two things: search and evaluate. First, the search function. Think of it like this: the engine is exploring a massive tree of possible moves and is trying to find the best path. Let's look at an example. When the game starts, white could go e4 or d4. And for each of these, black has a set of responses, and now white has a set of responses for each of those. We're only looking at two possibilities for each move here, but in reality there are a lot more than two candidate moves at each turn. An engine like Stockfish searches through millions of possible moves till it reaches a maximum depth. At the end of each search line, the engine must evaluate how good a position is for a player. That's where the evaluation function kicks in, assigning any position a score that tells us which player is winning. If you've ever watched or analyzed a chess game online, you've probably seen a bar with a number on the side of the board. This is the number that's spit out by the evaluation function. And when this bar shifts or the number changes suddenly, that's your sign that someone's made a serious mistake or a blunder.
So the rook now defends the black knight. How can Kokesh keep the momentum going before it's too late?
Oh!
Whoa!
What happened?
Something's happened. It did feel a bit wrong for Magnus to play this move.
I kind of want to see bishop takes h1 though. Just that would go down in all the chess books forever for history.
Oh my god! game. Whoa, what's happening?
Okay. Oh my goodness me, he has made a blunder. Okay.
He just dropped off the board, but the knights have disappeared at the same time. And
oh, look at Magnus. He realizes this is a blunder. What's happening?
wow,
Total
Magnus
blunder.
has blundered his queen. It took me.
Well, not you guys then, because you didn't see it. But if people at home, whoa.
We've seen a huge blunder on the
happening?
board by Nepomniachtchi.
So you can see how quickly the engine's able to tell that there's been a blunder on the board, and how even the commentators don't realize immediately what's going on. And how do the engines do it? How do they compute this evaluation score? Classical chess engines rely on handcrafted evaluation functions, which look directly at the board position, which is the placement of every piece on the board, and use that information to generate a numerical score that reflects who's better and by how much. A score of 0 means that the position is completely equal. A score of +1 means that white has an advantage of about 1 pawn, and a score of -2 would mean that black is ahead by roughly 2 pawns. Each chess piece has an associated material value. A pawn is worth 1 point, knights and bishops are worth 3, a rook is worth 5 points, and the queen is worth 9. The engines calculate the material balance on both sides and use this to estimate who's ahead in terms of pawns. But that's just the beginning. To truly get a sense of who's winning, these engines need to also consider positional factors, like how active your pieces are, or how safe your king is, or whether your pawn structure is healthy or completely collapsing. And to express all this detail and nuances precisely, engines use centipawns, a unit that represents 1/100th of a pawn. This allows engines to quantify even the smallest advantages or weaknesses of a position. A slightly better outpost or a vulnerable back rank, it all gets captured into this evaluation score. And every time you make a move on platforms like chess.com, the engine asks how much worse was your move compared to the best one, and that difference is called centipawn loss. And when you analyze your game on these platforms, the centipawn loss is what's used to give you feedback on your play. If you only lose about 10 centipawns, your move is nearly perfect. If you lose 80, your move was a mistake.
Bruh.
And if you lose 400 centipawns, that's a blunder. So now we know how the engine computes a score at the end of each search line. But how does it use the score to figure out what's the best move? This is where the minimax search algorithm kicks in. Let's say the evaluation for knight f3 is 3 and bishop c4 is 6. Here it's white's turn to pick the best move, and white's always going to try to pick the move that leads to the highest evaluation. So the e5 node gets the value of 6. Similarly, for the c5 node, white's going to pick the higher of the two options, and it'll get the value 4. Now it's black's turn to move, and black is going to pick the move that leads to the lowest evaluation. So we're going to pick the lower of 6 and 4, and e4 gets the value 4. We will then use the same strategy to calculate the evaluation for all the d4 lines. And finally, it's white's turn to pick the best move between e4 and d4, and since white's maximizing the evaluation score, we're going to pick e4 with the value 4, and we now have the best move in this position. This algorithm can even further be optimized by using a technique called alpha-beta pruning that allows us to prune entire subtrees if we know that it's not going to affect the final outcome. We will cover how that works at the end of the video, but we'll move on for now. So now we know the two main things an engine does. It searches through millions of moves and keeps evaluating which positions are better than others. But here's the interesting part, not every engine thinks the same way. How engines search and evaluate has evolved dramatically over time. Some just rely on raw brute force calculation and some manually crafted rules, whereas others lean on AI and use neural networks and develop an intuition for the game using machine learning. Imagine you have a friend who wants to get better at chess. They could try two approaches. So one way would be for your friend to just memorize every possible move and then every possible counter to that move and just keep going. And this would be slow and painful, but would be quite thorough. Or they could just play a million games, and over time they start recognizing patterns and ideas, and they just stop calculating and just by looking at a position are able to tell whether it's winning and what a good move might be. The first method is what a traditional chess engine like Stockfish uses. Before its AI enhancements, Stockfish could search and evaluate 100 million positions per second using this brute force approach. These engines rarely miss sharp tactics or a forced sequence of moves, and they thrive in open positions where raw calculation will usually beat intuition. But these classical engines do have their blind spots because they do not understand more unusual ideas like fortresses or a long-term sacrifice, because these more subtle ideas are not always hard-coded into their rules. And they can also suffer from something called the horizon effect, which means they cannot see past a certain depth, and they might make short-term plans or moves that only delays an inevitable problem. So those were our brute force-based traditional chess engines. But on the other side, we have AI-based engines like AlphaZero and Leela Chess Zero. Unlike the traditional engines, these AI engines can simply look at a position and predict what would be the best moves without having to brute force every possible move. These engines aren't manually programmed with certain rules beyond just the simple rules of the game, but they are trained through a technique called reinforcement learning. AI chess engines like AlphaZero and Leela Chess learn by playing millions of self-play games.
Congratulations, you played yourself.
So they keep playing themselves again and again, and they keep adjusting the parameters based on their experience. So if they win a game, they would reinforce the patterns that led to the win, and if they lose the game, they will weaken the choices that led to the loss. And when they do this over millions of games, they develop this human-like intuition, learning what choices are good and bad, kind of like how a grandmaster develops their instinct over time.
When you play chess professionally at a high level, your brain is really trained to narrow the search and to use intuition because you know there is a limited amount of time. So you're trained to recognize patterns and sort of make these quick decisions.
So while traditional engines like Stockfish brute force deeply in all possible directions, these AI engines are able to be a bit more strategic and aggressively prune the search tree. Kind of like what Magnus just described, these AI engines can use their learned intuition to just focus on what matters the most. Instead of evaluating hundreds of millions of positions like Stockfish, these AI engines might only evaluate tens of thousands, but each individual evaluation is a lot more computationally demanding. The AI engines intuitively understand more complex ideas like pawn majorities or long-term sacrifices or these complex trade-offs that traditional chess engines might only find maybe 20 or 30 moves deep. And of course, these engines have their weaknesses too. Their main weakness is that they highly rely on the quality of their training. So if there was this rare tactical resource outside of their search, because they don't calculate everything, or if the model misjudges some position which is rare, they could make a mistake. Plus, they're quite resource intensive and rely on these powerful GPUs to make each evaluation. And that's why modern engines today blend the best of both worlds and use this hybrid approach. Stockfish, for example, uses efficiently updatable neural networks that uses a model to make the evaluations but also does a brute force search in parallel. And this way you get both the depth and reliability of a traditional engine as well as the intuition and the pattern recognition that an AI engine offers. And this combination makes the modern engines extremely powerful. So over the last couple of decades, as these engines have gotten so powerful, they've completely changed the way people have understood the game in several ways. Computer engines have uncovered a lot of new strategies that would be quite unintuitive for a human and has completely revolutionized the way a professional would approach the game today. But we cannot have nice things, and when you have easy access to a program that tells you who's winning and instantly tells you the best moves, people are unfortunately going to use them to cheat. If you're unfamiliar with chess, you might be a bit confused about how exactly one might cheat during a game.
High-tech anal beads vibrating in a chess grandmaster's ass.
And cheating in chess is simply a matter of having access to an engine or any external information during your game. If you're playing online, you could be running an engine on a second device or alt tabbing mid-game to check moves in a chess engine. Or you could be using a friend to feed you engine moves remotely. And if you're playing over the board, you could be taking frequent trips to the bathroom to consult an engine. And of course, you might be getting subtle signals or gestures from an accomplice or a hidden device. The most obvious kinds of cheating is when someone uses an engine for every single move. So for every move of the game, they look at their engine and just respond with whatever the engine tells them is the best move. And this kind of cheating is quite easy to catch, and platforms like chess.com and Lichess might shut their account within a few games or even during the same game. But here's where it gets tricky. When you're one of the best players in the world, or even just a reasonably good player, you do not need to cheat every move.
Like, if I started cheating, you would never know. The thing is, like, I would get like a move here and there. That's all I need. Or maybe, imagine I'm playing a tournament. I just find a system where I get somebody to signal me when there's a critical moment. Like if there's a moment where a certain move is much better than the others. That's really all I would need to to go from being the best to being like practically unbeatable.
Top players need to cheat 3 times a game. Literally, top players know so much about the position that if you even insinuate that they might be better or worse, they might find the right move. But they really only need to cheat one or 2 times.
And that's the real danger. Cheating does not have to be constant, but simply strategic. And it's not even about knowing what the best moves are, but simply recognizing that this is a critical position or confirming who's ahead. For example, there's even been instances where a player unintentionally gains an advantage because all the broadcasters suddenly focus their cameras on their opponent's board after they've made a mistake. And even that is a useful signal for a player. But the chess platforms and cheat detection experts know this. And this kind of subtle cheating has become one of the game's biggest challenges, especially in the online era. Platforms like chess.com and Lichess host millions of games every single day, and catching cheaters and detecting unfair play at this scale requires a blend of statistical analysis and artificial intelligence, and other prevention systems that we will get into now. About a decade ago, cheat detection mostly involved comparing a player's moves with that recommended by an engine, and if a player consistently played one of the top engine moves, especially in critical positions, that would raise a red flag. Experts would measure things like match rate, which is how often a player's move matches that of the top engine line, or average centipawn loss, which we learned about earlier, which is how far a player's move deviates from the best engine move. It used to be as simple as noticing that a 1600 rated player is consistently playing as well as a grandmaster. And in over-the-board games, the arbiters or the chess referees would also keep an eye on other strange behaviors like, leaving the board more than usual, or any strange device like bulges or strange body movements, and that would raise suspicion. But these methods were not really good at catching the more subtle kinds of cheating, and even when they did raise suspicion, it was quite weak and it wasn't sufficient to really action upon. So enter Dr. Kenneth Regan, a computer scientist and one of the first anti-cheating experts, who developed one of the most influential systems in the early 2010s that brought a lot of statistical rigor to cheat detection. Dr. Regan's system wouldn't simply count the engine matches, but it would compute an intrinsic performance rating based on the quality of the player's moves. In simple terms, it uses engines to assess how strongly a player played in a single game or a series of games, and it converts that to an expected rating. This expected rating is then compared to their actual rating. So if an 1800 player is consistently producing moves at a 2500 level, beyond what normal improvement or variance might allow, this would raise a red flag. This method also gives partial credit for suboptimal moves, so it's not just top engine match or nothing, but it sees how close the move is to the best engine choice. And it uses large databases of human games to model what kinds of performances are possible. And by analyzing a large number of moves across a large number of games, it is able to generate a probability that a certain kind of performance is plausible by a human. But this method was quite conservative and would set very stringent thresholds, the goal being to avoid a false accusation at all costs. So Dr. Regan's method became a cornerstone of statistical cheat detection and is still being used by a lot of tournaments for cheat detection today. If a player's IPR is dramatically higher than their real rating over a statistically significant sample, then that could be a pretty good indicator of cheating, especially if it's also combined with other evidence. And what do we mean by other evidence? Because so far we've just been focusing on the quality of the player's moves to detect cheating, but there's so many other factors. For example, the timing of the moves matters a lot too. As you might expect, a human tends to think longer in more complex positions and shorter in more simple ones. But a cheater might take the same amount of time no matter what kind of position it is. Or they might do something strange like take a long pause and then blitz out a perfect sequence of moves. And these abnormalities could be another indicator for cheating. And on top of that, online platforms also track other behavioral signals. For example, alt-tabbing to a different tab, or strange mouse movements or clicking patterns could all help distinguish a genuinely strong player from someone who's just using an engine. And in order to leverage all these different kinds of signals, we have our next frontier in cheat detection, which is
big data, machine learning.
So unlike static rules, these machine learning models can take all these different kinds of signals, like the quality of moves, the timing, the mouse patterns, and they can learn to spot patterns in cheating that humans or other simple rules might miss. To understand how AI is changing cheat detection, we first need to talk about one core idea. the classifier. A classifier is a type of machine learning model that can take in data and it decides which category or class that data belongs to. You can think of it as an algorithm that takes in an input like an email or an image or even a game of chess, and it puts it into a category based on what it has learned. Let's look at an example. Imagine you're building a classifier to detect whether an image is a cat. We will first train this model by feeding it thousands of labeled images, some with cats and others without. In machine learning, all input data, whether it's an image or a sound clip or a chess game, is first converted into a numerical representation. For an image, this might just be a grid of the pixel values. At first, this model or the algorithm does not understand what a cat is. But over time, by analyzing the patterns of every labeled image, it slowly learns what features typically appear in a photo of a cat. After being trained on a large number of photos, it starts noticing patterns like pointy ears or whiskers or furry bodies or certain postures. And eventually, when you show it a brand new picture, it can say, hey, this has the features of a cat, and I'm like 97% sure that this is a cat. And that's what a classifier does. It learns from all these labeled examples and then uses that learning to make future predictions and classify data into the categories it's been trained on. Now you might see where we're going with this. How do we apply this idea to cheat detection? The goal is to build a classifier that looks at a game of chess and can categorize it as cheating or clean. In this case, instead of an image, the classifier sees a structured collection of data points from a player's game. Each game of chess becomes a data vector, which is just a long list of numbers that includes all the signals we talked about earlier, like the match rate or the centipede loss or the time taken per move. And just like with cats and not cats, each of these vectors is labeled cheating if we know that the player was caught and confirmed using assistance, or clean if we know that it came from a trustworthy source like a known fair player. And similarly, over millions of examples, the classifier builds an internal model of what cheating typically looks like across all the different kinds of players and situations. And then when new games are played, the classifier takes the game's data vector and outputs a prediction. Essentially, this looks clean or this looks like cheating, along with a confidence score. And this was just one of the strategies. Beyond classifiers, chess platforms can also use machine learning to simulate and profile individual players. Every player typically has a pretty unique playing style. What kinds of positions and openings they prefer, what kinds of blunders they make, how they respond to different kinds of positions, time management patterns. Using large amounts of historical data, you can use these machine learning models to then profile and even build bots that mimic how a certain player might play. And this opens up even more possibilities for cheat detection, because platforms can then use these models to detect anomalies, not just compared to other grandmasters or statistical averages, but compared to those players themselves. And all this is barely scratching the surface. Classifiers and anomaly detection are just two of several strategies you can use to apply machine learning to cheat detection. Behind the scenes, researchers and cheat detection experts are likely experimenting with a variety of models and also different kinds of data signals to keep improving the model's accuracy and performance. And moreover, these models are also regularly retrained with new data. So as cheaters find new ways to cheat, and as the cheating patterns evolve over time, these models will also learn to recognize these new patterns and continuously keep evolving to detect cheaters. Now, it might sound like we solved all our problems with AI, but there are real limitations to it as well. First, we have the problem of bias in the training data. If the data that was used to train the model includes false positives, then it's possible that the model inherits these errors and amplifies them. For example, if our cat detection model incorrectly labeled some pictures of dogs as cats, and then you feed the results of the previous version of the model into the training of the next, this effect would just increase over time. And this could create a bad feedback loop. If we aren't careful about removing the false positives from the training data, the system might learn to flag similar innocent behavior repeatedly, and this could keep amplifying its bias. And that's why the quality of data matters a lot too. So even if we assume the data does not include false positives, we would still like the games in the training data to span a range of ratings and playing styles, so that the model doesn't simply learn high accuracy means cheating. For example, here's Alireza Firouzja, a really strong grandmaster who was incorrectly flagged by chess.com systems when he was just a kid.
So we knew of this kid before anyone else did, and because he was racking up wins, and he basically reached like the auto ban level on our site. We didn't know who he was. He wasn't even. You weren't even a GM yet. You were like 11 or.
I am. Yeah.
Okay, you am, and we banned him. We did a manual review, and we said no. This is a human, a very strong human, but a human.
And then there's the problem of interpretability. ML models can often be black boxes, so even if a model flags a player for cheating, it is sometimes hard to say why. It could maybe point to a game or a set of moves, but it is still hard to say why the model thought this set of moves or that game was suspicious. So yes, these models aren't perfect, but they have made cheat detection faster, smarter, and more adaptable than ever before. Today's cheat detection at these big platforms likely use a combination or a multi-layered approach before flagging a player. So the games likely go through statistical modeling, behavioral analysis, machine learning analysis, and then finally, if a game is flagged, a set of human experts would have a look at all the data and confirm the findings before taking action. And this allows the platforms to catch both the obvious as well as subtle cheaters while minimizing false accusations. Chess.com, for example, claims to close 3,500 accounts per day. So cheat detection isn't perfect, but it's quite good, and it's only going to keep getting better. But what's better than cheat detection? It's preventing cheating from being able to happen at all. In high-stakes online events, players are often asked to share their screens, they're observed through multiple webcams, they're sometimes asked to install monitoring software on their machines, and sometimes even have physical proctors that make sure they aren't receiving any outside help. And even physical over-the-board tournaments have pretty strict anti-cheating measures like security checks, metal detectors, disabling electronic devices, and making sure the players play in a soundproof room. But these prevention systems can often come at the cost of a worse fan experience. For example, I got to go to the Chess World Championship in Singapore last year, and all their anti-cheating measures did make the viewing experience a lot worse. Since you had to leave all your electronics outside, you couldn't have a device so that you could listen to the commentary inside the playing hall. And if you're not a grandmaster, it can be quite hard to understand all the nuances of the position without the commentary. So you're quite literally just staring at two players who are often not even at the board. So organizers are clearly finding it hard to find the balance between strong anti-cheating measures while still offering an exciting fan experience. So as disappointing as Singapore was, I hope it gets better over time, and I've already noticed it be a lot better in recent tournaments. So we've talked about engines, cheating, cheat detection, cheat prevention, but this video would be incomplete without talking about the procedure. Vladimir Kramnik, former world champion who has a real passion for this cheating problem, has his own way of tackling players who he thinks have cheated against him.
Okay, let's do the procedure. Block. This is first what I do. Let's see the game review. I would give 98.3. Oh, very good. 98.3.
So after losing, he looks at the game review, which shows you an accuracy score. And I don't think the number really matters. If it's high enough, he hits block and report, and sometimes then goes on Twitter and starts ranting about the people who he thinks have cheated against him. Now, we've all acknowledged that cheating in chess is a problem, and it is something that everyone is trying to get better at detecting and preventing. But this way of just publicly accusing people based on surface level analysis is not really helping and has been causing real problems. But first, what is this number that we get at the end of a game review, and is that an indicator of cheating?
92.4, yeah, 96, 97, 90.1, like 87, 88, I guess. Mine should be more than 90, 98.3, 91.9.
So this number is the Computer Aggregated Precision Score, or CAPS. And Chess.com created this as a way for new players who don't understand the ELO system to get a quick sense of how well they did during a game.
But a CAP score is giving you a measurement of 0 to whatever engine we had. Let's say the engine is perfect, okay? How well you match that. A new player can understand, oh, it's ranked 0 to 100, that's like I got an A. And so we did this as a feature, not as a cheat detection tool.
So yes, engines are used to generate the score, but it's not at all an indicator of cheating by itself. But going back to Kramnik, one of the biggest takeaways from all the chess controversies and cheating scandals over the last few years is how much of an impact an accusation can be on a player's career, reputation, and their mental health.
But this is a sustained, evil, and absolutely unhinged attempt to destroy my life. And I really don't, I'm tired of mincing words at this point. He is trying to ruin my life. He's trying to inflict emotional harm, physical harm on me. He knows exactly what he's doing. And this is one of the most wicked people that I've ever dealt with. I'm not trying to seek attention with this, but the people who are buying into this narrative, they exist at many levels, including at the very top level. and they include a large number of chess fans. Like, this is doing very serious damage and actual damage.
Yo no les echo la culpa, ¿no? Pero sí les echo la culpa por hacerlo público, por publicar en redes sociales algo así, ¿no? Porque yo nunca he publicado en redes sociales algo así. Sí, nunca he acusado a grandes maestros, incluso a maestros internacionales, porque yo hay un límite de acusar a un GM. Es un GM, te va a ganar, ¿no? Y un GM conocido, mucho más. Es como ellos, ¿no? Ellos tienen un estándar de que solo alguna gente le va a ganar, alguna gente es mejor que ellos. Y yo, por ejemplo, le puedo jugar una partida perfecta a Nepo y obviamente él no se lo va a creer.
But as you say, I mean, he didn't outright accuse you, but if you print lists like this, asking questions, I mean, it is very insinuating. What did it do to you? I mean,
yes, basically I was shocked, and I was sleeping like 3 hours before the next day. I mean, at first I was not even sure whether he was accusing me or not. Okay, he was not, but some anonymous people that it's sort of accusing me somewhere across the internet. And basically my point is, of course, my results were not in top 3. And if I'm on the third place of the list, I guess it's methodologically wrong for sure, and maybe even numerically wrong. So I became shocked, angry, lost concentration, had some psychosomatic problems like sleep and sometimes even breathing. I mean, I have some mild asthma, so nothing serious, but those problems became a bit stronger at times.
And also Hans Niemann, you've probably heard of him, is another good example of this. And in case you haven't, here's a quick recap of the Magnus-Hans scandal. In September 2022, Hans Niemann stuns Magnus Carlsen at the Sinkfield Cup by beating him with the black pieces. After the game, Magnus withdraws mid-tournament for the first time in his career and posts a cryptic tweet online.
If I speak, I am in big trouble.
The chess world erupts with speculation. Did Hans cheat in his game versus Magnus? And if he did cheat, how?
Have you ever used anal beads while playing chess?
Hans is confronted and he denies cheating over the board in his game versus Magnus, but he does admit to online cheating when he was 13 and 16 years old.
So I cheated in random games on chess.com. Now, I was confronted, I confessed, and this is the single biggest mistake of my life. I have never cheated in an over-the-board game. Other, when I was 12 years old, I have never, ever, and I would never do that. That is the worst thing I could ever do, cheat in a tournament with prize money. They want me to strip fully naked, I'll do it, I don't care.
Hans and Magnus face again a few weeks later, where Magnus resigns after playing one move, clearly showing that he doesn't want to play versus Hans.
I just have to interrupt you because the game started and Magnus has logged off. What has happened?
Magnus has resigned.
He then publicly accuses Hans of cheating more frequently than he has admitted. Following this, Chess.com bans Hans and release a 72-page Hans Niemann report where they say Hans likely cheated in more online games when he was a teenager, but it showed no evidence that Hans cheated over the board. Niemann then sues Carlsen, Chess.com, and Hikaru for $100 million. The case is dismissed months later, and they reach a settlement. In the following years, Hans has slowly been reintegrated into professional chess. Hans and Magnus barely seem to be able to look at each other, but recently Hans has been able to show that he's quite a strong chess player and is able to beat some of the best players in the world, especially in faster time formats. In all these cases, the players have been publicly accused of cheating and then left to shoulder the burden of proving their own innocence. And this can be quite difficult, especially if the people accusing you are doing so in bad faith.
Yeah, it's the people who are like clearly mean it in bad faith or to, like, you know, drag your name through the dirt.
Yeah, you're the target, and now we need evidence against you. And since we don't have any hard evidence, it's like I say, okay, you're a murderer. And then you say, well, who did I kill? And I'm like, I don't know who you killed. You killed someone. And then I find out that as a kid, you got in a playground fight with another kid. And then I'm like, okay, well, he has a history of violence.
We've seen how cheat detection strategies use really high thresholds and err on the side of caution to prevent false accusations. And yet we've seen some people who've been very positive influences in the chess community subject to public judgment based on some superficial stats and insinuations. In the case of Hans Niemann, yes, he admitted to cheating when he was a teenager, but given the information we know today, it's hard not to feel like Magnus and Chess.com may have jumped the gun. Maybe they were just trying to send a message about the seriousness of this problem of cheating in chess, but the result was a guy who was suddenly vilified by the entire world and now feels like there is a conspiracy against him. Imagine being a teenager who becomes overnight infamous for allegedly cheating against the greatest player in the world. Now I get it, Hans might not be the most likable guy.
At the same time, you are kind of mean. Like, you are mean to me.
Well, I should be, yes.
But it's not hard to see why he might feel bitter and feel like he's up against this chess mafia.
When I stood up to them and I refused to sort of bow down to this chess mafia.
Okay, so how do we move forward? We could maybe start by keeping accusations private and follow some sort of due process, and let the experts take their time and come to a decision instead of trial by Twitter. Because once the internet decides you're guilty, clearing your name could be a never-ending battle. They're still making Hans do crazy stuff like take polygraph tests.
Have you ever used outside assistance during a live tournament game?
No.
Are you lying to me?
No.
But what is the due process? I assume it would involve trusting the experts at organizations like chess.com that have lost some trust. But the thing is, even if we do view chess.com through a cynical lens and view it as this company that is only motivated by profits and maintaining this monopoly over chess, they still need a platform that users can trust and has strong anti-cheating measures. And moreover, chess.com might be the best we have today because there's not that many teams working on this problem of cheat detection in chess.
And they have the best cheat detection in the world. They know that I'm not a cheater.
And even less so that have enough resources and data to be good at it as chess.com. This is not sponsored by chess.com. But in order to build that trust, platforms could continue making cheat detection more transparent and more widely understood. And I hope this video helps in some way, but we should continue building this culture of trust and not paranoia. Because I want to see the chess world thrive. I want to see more table banging and harmless genes drama, and less of seeing our favorite players spending their prime years defending themselves from these online witch hunts. And I want to see the wholesome Kramnik again. Not the one who's going after people on Twitter, but the one who is playing harmless pranks over the board. And that's the chess world we deserve. One with trust and one with pretty good cheat detection. And we can build it together. Alright, you made it to the end. Thanks for watching. Like, subscribe, comment, and I will see you in the next one. Goodbye. Let me know what you think. Now, comment, like, subscribe. Alright, for you nerds who stuck around to learn about alpha-beta pruning, here's how that works. Let's assume we've evaluated the E4 branch and it gives us a value of 4. This becomes the initial alpha value, which represents the best value white can guarantee so far. And let's say we now evaluate the D5 node and get the value 5. This becomes our beta value, which represents the best value black can guarantee from this position. And here's where it gets interesting. When we're evaluating the knight of 6 node, we have an alpha value of 4 and beta value of 5. Now let's say we evaluate the first child of the knight of 6 node and get the value 7. Now we know white at least has a move that gives a value of 7. We already know that the black player at d4 is never going to pick knight of 6 now because they already have an option with the lower value of 5. And we can therefore now prune all the remaining child nodes of knight of 6 and save all that computation. Because we know no matter what the values of those nodes are, we're never going to pick them because they would not change the outcome.